And now we get to semi-annual bonds. So far we've just talked about annual bonds and we haven't had to make any adjustments in the calculator. So here's the rule. Whenever you have a semi-annual bond, or if it was quarterly, you would put a 4 wherever you see a 2. But for semi-annual, we're using a 2. You have to adjust N, I, and the coupon payment. So for N, if it's semi-annual, that makes it compounded twice more often. So you're going to multiply 2 times N, and if you had the interest rate is going to be divided by 2 because it's an annual interest rate, but now we got to make it a periodic rate. And the coupon payment is stated on an annual basis. So if it was a $90 coupon per year and it was annual, semi-annual, then you would divide 90 by 2 and you get $45 every 6 months. And the reason why we go through these changes is because that way we don't have to change the settings in our calculator, because changing the settings in the calculator doesn't really help much, and it makes you a lot more likely to make a mistake in the future by not remembering to change the settings back. So this is really the best method, and you should use this method. So here's an example. We've got a 10-year, 10% semi-annual coupon bond, and the market interest rate is 13%. So instead of 10, we'll multiply 10 times 2 is 20. Instead of 13, we'll say 13 divided by 2, which is also up here, is 6.5. And then instead of a $100 payment, we'll divide it by 2 and we'll put in a $50 payment. And so I could input this over here. 20 is N, 6.5 is I. I'm solving for present value. So 50 is payment, and then $1,000 is the future value, and then I hit compute the price or the present value, and I get 834.72. So that's the price of this bond today, considering that it is a semi-annual bond. And then here's another question. Would you prefer to buy a 10-year 10% annual coupon bond or a 10-year 10% semi-annual coupon bond, all else equal? Well, we've already talked about the whole more than annual compounding thing and the effective annual rate of return. So anytime you have a chance for more than annual compounding, you want that. So you would want, and you can just compute the effective annual rate for the semi-annual bond. And remember, we had a way to do this in the calculator. If I go over here, remember I go to second interest rate conversion. I put my nominal rate in and it's 10%. I hit enter to make the number stay there. Down, go past this, down. It's compounded semi-annually, so 2 and enter. And then I could go back up and hit compute. So the effective annual rate's 10.25. I would rather have 10.25% over 10%. And then now we have like a kind of a strange question. If the price for this semi-annual bond was $1,000, what would be the proper price for the annual coupon bond? So we have to look at this whole semi-annual rate and use that to discount the cash flows back to figure out what the price would be for the annual bond. And so you have 10N, put in your effective annual rate for interest rate and your $100 payment and the $1,000 future value. And we're not dividing anything by 2 because this is an annual bond that we're discounting with a semi-annually compounded rate. And so if you entered these numbers into your calculator, you would get the $984.80. So I don't really care for this example that much, but this is how you would do it. Now we get to yield to call. So we talked about how some bonds are callable. Well, really a lot of bonds are callable. And now we have a 10-year, 10% semi-annual coupon bond, and the price is 1135.9. And it can be called in 4 years for $1,050. So what's the yield to call? If this bond is selling at a premium, that means interest rates have gone down in the market, and the company should be very likely to call back the bond because they should be able to get a lower interest rate. So if it can be called in 4 years, and then also remember that they said it was semi-annual, we've got 4 years, but 4 times 2, so 8 is what we put in for N because it's semi-annual. The price we were given, the payment was 50, and then instead of putting a future value of 1,000, we have to put the call price and the future value. So this is the one thing that's really different with calculating yield to call. Now keep in mind that the $50 payment here is $100 because it's a 10% coupon bond divided by 2. So if I put in 8N 1135.9 as the, oops, I need to make that a negative and put that in as the present value. 50 is the payment, and then 1,050 is the call price, so I put that in as the future value. And then I hit compute I, and I get this 3.568 number. Well, when the calculator solves that, that's the periodic rate for 6 months. That's not the final answer. So to get the final answer, we just take that 3.568 and we have to multiply it times 2. And so the real answer, the final answer, is 7.137. That's the yield to call. And if you wanted, since this is a nominal rate, and all of the bond rates that we end up calculating are nominal, if it's annual, you don't have a problem. But if it's semi-annual or quarterly, if you wanted to know the effective yield to call or the effective annual rate, you would have to go through your calculator, the second interest rate conversion, and I would put in the 7.137 as the nominal rate, since that's what I calculated. An arrow down to the compounding periods per year, and it's 2, so that's correct. Arrow up, and then it just keeps the last number that was there, so I'm going to hit compute. And now I see the effective annual rate is 7.26%, and that's this extra step that they did here. We don't normally do this extra step, we just kind of always look at the nominal rate whenever we solve something. If this had been a quarterly bond, we would have multiplied this times 4. So just keep in mind, is it quarterly, is it semi-annual, is it monthly? And you'll have to make all those adjustments. So from this previous example where we were calculating the yield to call, the question would be, which we've kind of already answered, is if you were an investor in this bond, would you be more likely to earn the yield to maturity or the yield to call? And we would be more likely to earn the yield to call of 7.137% because the firm is currently paying $100 in interest expense, and now it could go down and reduce its interest expense to $71.37 per bond. So it would be logical for the firm to call the bonds back, save interest expense, and that would increase their net income. So always remember, if you see a premium bond, you should earn the yield to call. If you see a discount bond, then you should expect to earn the yield to maturity.